evening, everyone. Welcome to the data science program. Today we are starting a new module. It's called as a Tableau. So we have been come across many of the data visualization techniques so far, but when it comes to the business intelligence, right? You will get a huge data, and you have to make a variety of data representation, right? Without doing much programming, right? So programming version and getting into the visualization part, we have the various tools such as Matplotlib, Seaborn, etc. We have, but our intention now is to move ahead to the business intelligence part, right? Which is going to be a part of our data science course towards the end when we discuss the business analytics. If at all there is a content which needs to be dealt called as business analytics, right? There you discuss about the data handling and the data analysis specifically related to the what is called as the business analytics. Okay, maybe the finance or various other aspects will be discussed right at that particular point. But if it is there or if it is not there, that doesn't matter. Tableau is considered as one of the very important data visualization tool when it comes to the business analytics. There are specific openings, or in many of the companies there are specific requirements, right, for Tableau developers. Those who work with Tableau, and their job is to get the perfect visualizations, right, related to the Tableau. So we have a particular module uh, which is present at the middle of the course, though we are not dealing with any of the business analytics parts right now. This is just to give an idea that, right, if at all we introduce the Tableau at this particular point, right, those who want to work in that particular direction can can take some time and can spend time on this, and can start working on it towards that direction now itself. Just want to give an idea about that. That's why we are bringing the Tableau at this particular point of time. As I mentioned, it is a visualization tool, data visualization tool, very powerful and very famous, right? When you say what are the, if at all we consider the business related tools that are used, right? One is Power BI, that is from the Microsoft, and the second one is Tableau. Okay, so those two are very famous. Anyway, I'm going to show you one pictorial representation how what are the various tools available and how famous they are, right? That's going to come towards the end of maybe today's session, or at least the first half of tomorrow's session. Okay, so with that introduction, we'll start the session called the Tableau. It's a software, right? So Tableau itself is a software developed by a company called the Tableau itself. All right. So before that, we had discussed the importance of data, and also we had discussed the importance of the visualization of the data. Okay, we'll start the session with the introduction to the data visualization. Few parts of this particular section we already have discussed, right? So what do you mean by data visualization? If I ask a question, right? Definitely I'm going to get the answers in various views, but your ultimate highlight will be on the same thing, right? You will collect the data sets from various sources, various representation in various formats, right? And the data visualization is a particular way of having the visual aid. It's going to provide you a visual aid to get the insights of the data, right? So we should be able to visualize if at all the data contains classes, right? I should be able to see that, okay, the data set has so many classes, right? By looking at a proper visualization. Every visualization will not give you that aid, will not show you that, oh, there are classes like this, right? A specific, appropriate, right? Many options we have. Appropriately, you choose the visualization. If you choose that, definitely you will be able to see that, yes, there are classes. Like these are the various classes present over there, right? Again, when it comes to the huge data, right? It may not be very easy for us to get a tool which provides that sophistication of uh, clearly showing the contents of the particular what you call as the data, right? So it is absolutely necessary that you should have a powerful tool which gets an ease of access. You should be able to access that easily. You should be able to, you should not do, right, a lot of coding. There is a tool which you have to do a lot of code, then only it will give you a very good picture. Means again, that is also not suggested, right? Easily you should be able to handle it up, right? So also you need to have a, variety of graphically supported visualization that should be coming into picture. That's also another requirement of this. Again, you should have, right, look at the last point. It says that well designed data graphics is what is required to see various types. Maybe you want some want in 2D, some want in 3D, some want a lot of colors to be present, right? Vibrant colors. Some don't want, some wanted to keep it as simple as possible, like that, right? So you should be able to visualize with the graphics, right? With the very what you call the ease of use, right? You should be able to use it in a very simple manner. Yet it should be very powerful so that it should be able to handle a huge data, right? So if you are able to do all this, right, we will call that as a perfect data visualization, right? You should be able to handle huge data, very important. Okay, let's look at a very simple example, right? So if I give you the, if I give you four different data, okay, four different data sets as shown in the columns that you can see over here, right? So let me say, let me bring up the pen here, just a second. Okay, so as you can see, let me say I give you this four, right? Four different data sets, let us say. And I will ask you, right, what is the content, right? If you don't go for any visualization, you do the maths, you take a mean, you take a variance, you take whatever parameters you take from that, right? Still you will not be able to get a clear picture saying that, okay, this data set is like this, right? I cannot give a very straightforward uh, uh, details or straightforward comment about the, right, the structure of the data, right? Any four of them, you see all the four, right? For my eyes, everything looks the same. Okay, everything is same for me. Even if I take the values like, right, everything you have here, right? So they are pretty much close, right? Maybe mean, variance, covariance, whatever you take, right? There are types of data, right? When you process and take some of the coefficients like this, mean, variance, covariance, right, or anything you take, pretty much they all look same. So I anyway, so in this case, you see that they are less, maybe 10 or 15 points in each of the columns, right? So this looks, this even if there are only 10 to 15 points in each of data set, still it is not possible to understand what is that data. X varies, Y varies, I can see them. Yes, that's, other than that, I am not able to say that any other characteristic. I am not able to guess any other characteristics from this particular data given. So now the importance of, now if at all I plot, right, I'll be able to understand what is the importance of visualization. I'll also be able to understand the power of the data visualization. Why the visualization so necessary? It's for a simple reason. You see here, right? So the first, second, third, and the fourth data, when you plot, you get these four. right? So that means, right, you can see that, right? So very easy. I don't have to tell even a single word. You understand that, okay, this is how the data is. So maybe for a third one, if I see this, I will be able to understand that, okay, it is actually forming a straight line very close to that, right? So, right, like that, I'm able to, right, guess something about the data by simply visualization. I don't need any explanation. So the visualization is necessary because of that. It's always not possible to go with the explanation or data analysis part without having a data visualization. So whenever you have the data visualization, many more things can be understood without any explanation related to data. That's why the data analysis part definitely has a visualization part coming in the picture. Any of the exploratory data analysis we did earlier, or the data pre-processing we did earlier, right? Any of the previous sessions, if you consider, right, there was one or two or few data visualization, right, included in that. That is just because of this reason. Okay, so now you understand that yes, data visualization is necessary. Okay, so when it comes to the, so data visualization comes under a specific part which is considered as a visual analysis. Okay, so what do you have inside the visual analysis, right? What are the various parts, right, that you can touch if you do the visual analysis is what we are trying to understand. Again, right, we have to slightly move away from only the data analysis. We need to slightly move towards the business part. Okay, so because ultimate goal of our session, the module is the tool, right, that is used for business analytics. So I have two different pictures over here. On the left side, it is a general one. On the right side, whatever you see is a specific towards the business part. Okay, so on the left side, you can see here, right, what happens, what is the use when you do the visual analytics, what all the things you can do, right? So the first one, I'll start from here, information analytics. I'm able to it's not necessary that always you do that, but you can touch this. Whatever is the information content in your data set, if it is providing like steep increase in the cost of an object, I can detect that steep increase. So price hike is what is the information. So numbers will increase like that. Okay, if I just see the data, I don't understand. But when I plot it, I will be able to understand that, okay, at this particular point of time, or at the month of May or June, right, there was an increase in the steep increase in the price. This is what information increase. So temperature is very high, right? Means the day is hot. You will be able to get that information from that. Okay, so one more analysis is related to the geospatial, in the sense the location based, right? So maybe your data set contains the price of maybe say fuel charges, fuel prices at different locations of the country. Location wise, what is happening, right? If you plot the price hike or the normal, not hike, price of petrol for in a given month for various locations of the country, you see you are actually extracting the information related to the geolocation, geospatial. So that's what is a geospatial. Then scientific analysis is possible, right? You can perform various scientific, right, analysis by looking at the data, the visualization, provided your data is scientific, then you can do that. Okay, then you look at the various parameters over here. It's called as a knowledge discovery. Whatever I already have, right, I can try to update that. I thought like this, but this data is telling me something else. That's what is knowledge related, right? Whatever was there in my knowledge, I'm actually, right, exploring that further. Then you see the data management, knowledge representation, right? I try to represent the data in a specific format. maybe I have to slightly modify that, right? So that's the data management and this. Then look at the next one. It says the presentation, production, and dissemination. Okay, so right, as it suggests, right, I can understand how I have a data set, right, represented in this format. I get a very clear picture of that by using the visual aids. How do I represent it to others? How do I present, right? So presentation, right, is also going to be done by using the visual analytics, which also supported by the production and dissemination, right? Then cognitive and the perceptual science. So here you can see that there is a field called the cognitive perceptual science related, right, discussion, right? So that can also be analyzed and represented by users. So if at all, say there is a group of people doing a project, right, then you can see that the results of the work or whatever results you obtain so far by using a visual aid for representing that, you can definitely perform what is called as an interaction, right? You can interact and discuss and proceed further, right? So these are the various scopes of the visual analytics, right, in general, if you want to discuss. But if you want to go to a specific field, all of them are applicable, but we'll try to define that in a slightly different way so that it comes under the business perspective. Okay, so the first one is, right, you can move any direction. They're not in a sense they're not ordered in a specific way. So you can see I'll start from the top. So the first one says better decision making, right? Maybe it's an investment based, right? So I just have to look all the performance of again, example, stock. If at all I want to install in a stock, I have to be careful. I have to, right, look into various parameters, right, of that particular stock before I invest. So considering that, the better decision making, right, it will help. It's not the only tool you should use. You should go for others as well, but the visual analytics will help you in that aspect as well. So the second point is better sense of risk. It's one and same. It's another version of the same point which I mentioned earlier, right? If you will make a decision, right, of investment based on the risk factor, right? So better decision means less risk, right? So they are actually going hand in hand always, right? Then if you can use the visual analytics properly, definitely you can go ahead and maintain a better customer relationship. What are their needs, right? They will be specifying in a data set, right? But I don't understand the data if I just look at that as. So what is expected, you visualize that data in a proper way so that you can meet their requirements and you can maintain a good relationship. Okay, then strategic initiative, because you are going to come up with a say a new product, right, or something like that. In order to make that product successful, the marketing strategy is important. How do you market that? So for that also you might have requirements related to either the past customer relationships or past feedbacks, right? The previous version of the same product, what feedback you got from the market, etc. You may have to visualize that as well, right? So considering that, you will be able to go for a better strategic initiative, as well as the financial performance, which is the last point that is written over here, right? That is also pretty much important, right? Everything is possible, right? Not by just using the visual analytics, but by also using visual analytics in addition with the all the other tools. Okay, now, so what is the standard procedure of the data visualization? So data visualization means I should have a properly collected data, preferably structured data, right? Normally in the form of a table. So many rows, so many columns. Columns will represent the various features and rows represent various samples. Person one, okay. In the sense, item number one, what is the cost, from where I collected, whom you are going to deliver. You see the columns will remain same for every row element, Like we expect a very structured data, right? That is what normally we get whenever it is already stored somewhere and it is kept in a very specific form, such as the server. Already we have seen one version of that. It is actually when we discussed about the SQL, you should be able to recall, right? So there is a structured data available in the form of the table, right? So very similar formats, other formats also there, but they will be considered as the structured format only because somebody will be processing that and storing it in a secure space, a huge space, right? We will call it as a server. Okay. Now, in order to visualize that, right, my first requirement is the data which is collected, right, has to be right in particular format. We'll call it as a structured data. Right. Again, there are multiple options available. I may not have the data sets in the same location. One server has one part of it, another server has another part of it. A third server located at 5,000 miles from here has a completely different data set, right, etc. Now, the options could be something like I have to club all of them together, right, so that it becomes the actual data set, and then I can. For that, you have some, maybe you have some restrictions, like one of the data is collected from, sorry, each of the data is collected from different types of sensors, maybe temperature data, humidity data, or rain data, etc. You see that, right? Everything is coming under the weather data, but you see everything is different. You should bring all of them together, right, by doing what is called as the integration format. This is the integration. The first thing you what you see here is the integration, the leftmost side. So integration is necessary because whenever I do the whenever I try to visualize, right, I want various parameters, they have to be in a very structured form, right? So like, okay, first column is temperature, second column itself is the humidity, third is the height or the maybe the XYZ coordinate of the place where I measured this, etc. You see, it has to be in the format. Randomly, my first data set contains first column something, second data set, first column is completely different thing, that is not possible, right? So you call that as integration. Integration of the data sets, different data sets. Why there will be different data sets? Because they are located at different location, different geographical servers, plus their origins may be different. Okay, so there is also a possibility that I use the temperature sensor only, but use different hardwares to collect them. Why? What makes the difference when you use, say, a Raspberry Pi at a location and a Arduino at a different location? The numbers are represented in different formats by each of them. Correct. So you see, one will use 8-bit representation, other one might use 16-bit representation. So I have to bring everything into the same thing. So this integration, whatever we are performing here, right? So this information, this integration takes care of everything. Every problem I mentioned so far will be solved by this. Everything, every data, right, will be coming under the out of this. You see here, there is actually something is being, some processing is happening, because of which everything will come as unique out of this. Same format, it will come out. Just think like that. Okay. So everything will be same, like everything is 16-bit representation, right? You keep only 4 decimal places like that. So something will be done. So that's what is integration, right? Why the integration is required? You understand? Data coming from different what we call hardwares, different representation, etc. Yes, Rohan. No. This is just a representation. Okay, nothing happened. Nothing like this is not any practical this thing. Okay, some I just have to show you that if I just write a point, it becomes right. It becomes very boring. So I just brought in some pictures over here. Okay, so it's just like collect the data from different sources, put it into actually there is a software which will run, okay, that will convert everything into the same format. Like first column only this I want, irrespective of what data set it is. Again, some might have collected the temperature in Celsius, some might have collected it in Fahrenheit or any other Kelvin. Everything has to be converted into the same format and put it in the first location itself. This is my rule. So that will be done by this first block, whatever you see here. So on the top, what you see here is simply like, right, they are the different data formats, right, collected by different hardware, represented in different formats. Everything will go into this and come out as a uniform format. That's all. That's what is the meaning of this first particular blue colored block. I hope that is clear. Okay, so the next part. Now I have a data set in the structured form. I'm going to call it as a structured data, right? So we have to perform various types of analysis on that. In the sense, you may use a formula because outlier detection means, just an example. If I want to detect outlier, I know that I can use IQR, interquartile range. Just an example. This is not the only one which we are using for analysis, right? So you do an analysis such as that. Whatever is outlier, remove that. Remaining data only you keep. So that such processing is what is happening, right, inside this block called analyze. So these are the various representation that you are processing something, right? You are analyzing something. You are passing it through some equation, right? Analysis. Is it required? Is it not required? Remove the outliers and keep them, etc. Other processes you are trying to do. Whatever comes under the analysis part is what you are trying to do over here. Okay, so that's the second part. You do the analysis. After the analysis, now you are ready for the visualization. You bring the appropriate plot, right? Right? Very simple. Maybe the pie chart is one I want. I don't want pie chart. I want bar graph. Anything, any plot that comes in the picture. Only after doing the analysis of that data, you can give it for the visualization, right? Which is going to bring up the data using a graphics in front of you on your screen, right? That is what is called as a visualization. Okay. Yes, Manish. Yeah, that is horizontal bar chart. Okay, so this is horizontal bar chart, right? Fine. So you have multiple options. I think in Matplotlib, Seaborn, when we discussed, we have discussed varieties of graphs, right? Any of them, if it is suitable, you can bring it up and you can visualize that. Yes, Ruchi. Ruchi, do you have a question? Okay, all right. So let's move ahead. So far, we were discussing about the visualization. Now the question comes, then what's so special about Tableau? So we have already um, done many of the what you call visual data visualization tool we have implemented. We are very happy. So why do you want to go ahead, right? Why do you want to bring a new thing? Okay, so there are some of the features which are not present in any of the tools which we had discussed or which we are using, right, during the programming sessions. Okay, so one part is called as a flexibility, right? Flexibility in the it comes into picture uh, because I can bring varied the integration part which we had seen earlier, right? That can be done even here. I don't have to perform the integration at a different stage. You don't have to club everything and bring it into the same format and give it to tab. That was a requirement for our other data visualization tools. But here, get the data from any type, any format, anything you have, you bring it, right? So that's the flexibility which we are talking. Okay, you bring it, do the integration here inside the Tableau, and you go ahead. You will be able to visualize, right, after the integration inside it. That's what is supported. Okay, and it is pretty much intuitive, interactive visuals. I'm going to justify this when we are taking up an example and show you all of them. Okay. And once you have the data set with you, the time required for the production of the very complicated what you call uh, visualization is nil, right? Compared to other tools, it takes no time to bring up. As soon as you give a data and you tell that, okay, this is the plot I want, immediately it comes up, right? With a lot of improvement compared to any other tool. Okay, so that's one thing. And in addition to that, we have what do you call inside the intuitive and the intuitive part, right? Inside the Tableau, you can connect uh, this particular tool to the servers directly. Like SQL, we used to write queries, right? So bringing the data from a server is possible using the queries as well. See, that is not supported in any of the tools which we were using so far, right? So that's why the Tableau is actually very famous, because we are not going to on a real time scenario, you may not get to work with small CSV files which we use to uh, teach you the concepts, right? Like maybe, right, IMDb data set which we had used earlier, or something, some data set, though it looks like pretty big for you, because what we have used might use 1 lakh data, right? 1 lakh is the size. We will never use such data in practice, right? You have to go to a server, link your device to a server, load the data from the server and process. This is the fundamental requirement. Anyway, we are going to reach that in the course. We will be reaching that at the end. But practically what you will be doing is only that part. Okay, so because of that, right, visualization also requires you have to bring a huge data set from some location to your system and then visualize. So, and none of the tools will do that, right? You have to bring a completely new library, right? Reload the data takes some time to come to your system has its own issues, etc. Many things will come into picture in that case, right? So normally we should be ready to solve that. Now all those burden is taken away by Tableau. Again, some of the queries are supported over here, right? Using those queries, right, you can bring the data, you will conditionally read the data, and you will run that over here, right, with a very high and very sophisticated visualization. So all these things happen with the last point saying quick production time. You'll be able to see that in no time. Okay, so those are the fundamental features, right? There are very few features which I'm mentioning here. There are much more features, advanced features, which we are not aware of. I'm not able to bring them now because we don't have any idea what they are. Okay, so that's the uh, just 5 simple points in which I can say that what are the fundamental features. Okay, so with that introduction, now we'll see that what is Tableau. It's a software, right? So Tableau is the name of the software company which produces the tool for visualization. They call it as interactive data visualization product. Okay, interactively you can, right, simply drag, drop something, give an option, something like that. It's going to work in that way, right? Uh, Hard programming is not at all required, very little bit, right? If at all it is there, it will be very minimal, right? Not like the Python program you write to get a very good visualization. You may have to write 10 lines of code saying that this is the option, this color, this bring in this particular library and use this part of the library. No, that's not at all required. Okay, so that's the first thing. So just understand, it's basically interactive data visualization, and you are more concentrating on the BI, which is a business intelligence, right? So it doesn't mean that you cannot use it for other purposes, but the product is brought into market for keeping in mind that, okay, for business intelligence it should be used. Okay, right. Now it's one of the largest organization, right? And they are using the data and the people as a very valued assets. Okay, so they are allowing their customers to spend, right, more time on data analysis. In the sense, if you have a visualization, clear visualization is available for you, right, then if you have a very clear visualization available for you, then that means what? You can spend less time okay, on arranging your data. That's actually waste of time. I spent 2 hours on arranging my data. Data visualization gave me nothing, means it's of no use to you. That's why data wrangling is less, more on the data analysis. Okay, so that's what is the point here. So we have a question: how Tableau is different from the Excel, right? I don't think you can connect to a huge data server database, right, in uh, Excel and do the visual. Simple visualizations are supported in Excel, right? For not for handling huge data sets. Excel has limitation, whereas Tableau overcomes that limitation. Okay, so fundamentally you may see that okay, both are visualization tools, but there are differences, such as Tableau is specifically for some for a purpose, right? Interactively you can actually change the parameters, right, which are not, according to me, is not possible in case of Excel. Okay, other than the data handling capabilities, these are the fundamental differences which we find between Tableau and Excel, right? Okay, right. What is a Tableau architecture? Right, again, this is a general diagram. So what are the various data sources you can connect itself is too huge. Look at the leftmost side. Okay, so the leftmost side says, okay, these are the various data sources to which we can connect, right? Once we install and once we start working on that, I'll be able to show how to connect to each of them. We may not have such data set available with us right now, but in future, if you want to connect, yes, we have that facility. I'll show you that. But just look at the name. So many are there. Okay, everything is possible. From Excel also, I'll bring the data to the Tableau and I'll show the visual. Okay, so that's also possible. CSV file, Excel are the most common one which we might use in this course. But yes, you have a facility to connect to any huge database server and you can bring the data, right? So reading that is on the leftmost side, which is the first part, right? So you may extract the data. Okay, so the second part, right, it's connected to a server. From the server you may get the data to and you can visualize. That's what is happening here. Otherwise, right, if you bring it from one location to your system, you may have some security clearances required, etc. So those are also supported, and also you can put it in various other types of modules, such as you can create a repository, right? You can have a automation system, right, which takes care of your data, right, etc. Right, you don't have to go for separate entities that's supported in the tab. So after bringing the data from a server, loading that, directly visualize, extract and visualize, that's the first option. Second one, you can make these modules possible, right? You can implement them internally, right? That's the second part of the Tableau's architecture. And once you have the data set in a specific format, you have it ready for you. You don't want to go with the direct visualizations, right? You have various other advanced parameters, right? So this was the extraction and visualization. Other than that, what are the advanced things you have? If you don't understand, don't worry. We will be, those are the pretty much advanced for advanced users of that. So our intention is not to go to that level, but I have to tell you that, okay, these are possibilities. So you can create what is called as a workbook that comes under Tableau readers, right? You have a data, you have created a visualization, just keep it ready for reading. Nobody can alter that, nobody can modify that. Keep it as a readily readable, like PDF. If I have a PDF, I can just go through that and I can close, or if I don't want, I delete. Something very similar to that. Tableau readers, right? What are the various versions of Tableau? I'll come to that. Then also you will see a similar type of this. Then, right, inside that, inside that reader, we have few options. One is static, right? So this is called as a static reader, and another one, if you can modify your content according to which device you are going to read, right? It's a web, mobile, etc. You have what's called as a Tableau server, right? You can actually put it over there, etc. So, right, don't worry about this last part, right? As of now, don't worry, right? This mostly we are interested in this part, right? In this particular module. right? We are not worrying about others, but I am telling you what are the possibilities. After finishing a basic course on Tableau, you want to go for become a Tableau developer, yes, please go ahead. A lot of opportunities are. Okay, fine. Now we'll move to the actual installation part, right? Anyway, I'm just giving the installation part now itself, so that, right, those who are going to work with me, along with me, when I do a when I give a demo, right? If you are also interested to go along with me, you should be ready with the software. That's why I'm giving the installation. But anyway, after the installation session, we are not starting with the demo immediately. Okay, you get some time, right? I don't know if I cover everything today. We may start the demo session towards the end of the day today, end of the session today. Otherwise, it will be only in the tomorrow session. But you get some, yes, enough time to install. That's my intention for discussing about the installation initially. Okay, so installation actually is a quick process. We can directly download the files from their servers, and we can see that, okay, that is getting installed over here. Okay, so we'll start step-by-step procedure, right? So if you are installing right with me, it may not be possible to install with me because this will take some time. Download is around 500 MB file, so that's going to take some time, but at least take a snapshot and keep it ready in your phone or somewhere, so that you can right, even if I move ahead, right, you can refer that and you can follow the procedure. So the search that you're going to do here is called as download Tableau public. Tableau is a paid tool, so every feature is not available for a free version. But anyway, it's actually a costly software, so we cannot afford buying a full version either. So what they have separated the key features and kept it for public usage. That's present in the Tableau public. So you just search for the Tableau public. So this is what the screenshot I have taken when I installed. Okay, I had a version earlier, I uninstalled, and just for this class I actually have uh, I have taken the snapshot by doing the installation again. So just see, when you search, right, you will get the public.tableau.com, which says that Tableau public free data visualization tool. Okay, so there is no, as of now, I don't see any version name here. Latest one is available. Okay, I'll go to the next page. You'll be able to see the version as well, I guess. Okay. Uh, exact number I don't remember right now, Manish. Maybe when I move to the next slide, you should be able to see that, I guess, on their web page. So when you click on this, right, the Tableau public, right, this page is open. Okay, so you can see the Tableau public, and it says that download the app, right? I think that is the one which gives you the most recent app itself, I guess, because the version name is not visible here. Okay, so take a snap of this and you click the download the app. That takes you to the next page. Okay, again, I don't see any version name over here. Okay, let me know if anybody see a version name. Please put it on the chat box so that Manish is asking which version is this. Okay, so let's see. Okay, I didn't see the version name yet. Right here it says that 2022.2 available for Mac and Windows, right? Mostly I think that's the one. Okay, can you see here 2022.2. Okay, so once you click this, I think it's going to ask you to sign in, right? So just you give the details and then you click on the right, download the app, right? As soon as you fill and click that, right, I will get a window saying that, right, it will be downloading now. So you will get a separate window showing that, okay, downloading progress. So once it is done, right? As soon as this came, a window popped up which said that, okay, downloading is in progress, and right, I got a file downloaded into the downloads of my system. All right. Yeah, now you can see the version name. This is the version which is installed in my system. Same number, 2022. Okay, so you will have to, uh, once the download is complete, it may take a few time. The amount of time taken depends on your net speed, I guess. So after the download is complete, go to that folder, whichever is the file downloaded, double click on that. Okay, so you will see that you are going to install the public edition of the Tableau, right? And simply click on this, right? And go to the install part. It says I'm going to install now. So it will be installed. Again, simply I took a snapshot in the middle during the progress, right? As soon as it is over, you will get a window, right? That's the Tableau window which we are talking about. So you see the Tableau public is there over here. It's a public version. The free version. Okay. So that's the installation process. We want this to be ready with you. If your intention is to work along with me whenever I do the demo for you. Okay. But that's not going to happen right away because we need to learn many more terminologies associated with the Tableau first, right? So the next half will be the same thing. We will be trying to explore various options, right, that are possible, right? Various terminologies, various components, etc. We'll explore them first, right? Not on the software, right? I already have prepared the slides corresponding to them. We'll go through them. We'll get familiar with each and every words that are supposed to be understood before we start working or before we do some hands-on the tab. Okay, any doubt with the installation or any slides you want me to repeat, right? Please tell me. Okay, or if you have doubt, please go ahead. Yeah, so the details I'll be able to touch when we discuss that. So there is a if you understand the word called automation, whatever it means, it can be done using the tab. Okay, but details of that I'll touch when we discuss those topics, because right now it may not be appropriate directly to jump into that. Okay, sure. Okay, so I think we are fine with the installation part as well as the procedure, right? Let's move ahead. Okay, let's try to understand the Tableau now. So our next intention is to understand what is there in Tableau, right? So we'll move ahead, right? So one option you see on the leftmost side, right? After the installation, whichever window pops up, there is an option called Connect. Okay, so in Connect, you can see the various uh, types of data, right, or the files to which you can connect, right? So on the leftmost side, so when you click on the Connect, and you will get a particular what you call window popping up. Again, right now you may not go to that. You simply see this, just try to understand, right? You can, if you have a data set in the Excel format, I can click on the Connect. That will take me to a new window. Okay, and in that window I can select, right, and I can say that, okay, this is the format to which I want to connect. In the sense, I am able to connect this Tableau to various types of files and various types of servers, various other types of data sources as well, because again, some of the features are not available in the free version. Okay, but just understand. Okay, So this is whatever we have is enough for us to understand the whole process. Okay. So first thing is connections, right? So what do you mean by connection, right? We can connect the Tableau to various files, various servers, and various saved data stores in such a way that we can bring the data that is present over there into the Tableau for visualization. This is something like loading the data in simple terms, right? You can connect to multiple file formats and servers, right? That's the first thing. Connections is a link which is going to help you out to perform this particular objective. It's very simple, very important, and the most basic step we are going to do in Tableau, right? Because Tableau will not help you generating the data or processing the data or doing anything with the creation of the data, right? So for that reason, you have to connect your Tableau to some file format at least, right? We will be doing most of the time with the CSV or the Excel sheet itself, but yes, you can see those are the options available, right? So don't worry if you don't have all the options in your system, because what we are going to use is a simple, right, the public version, right? And then, all right, in the connections, once you connect, what happens, I'm trying to show you, right? So let us say we have connected to a particular file. Again, the same file is the one which I'm going to show you, right? There is the Tableau has given some of the standard data sets available along with those installations, which you will be also having in your system now because you have installed, let's assume, right? So one of the data set is called as a superstore data set. Okay, so it's about what are the various order a superstore received, right? What is the cost, right? What's the ID of the order, who is the customer, what segment that particular order belongs to, etc. Many things are there. That's also a huge data set. Okay, so when you connect to that, right, we get a window, right? Whatever we see over there, right, is called as a dashboard, right? So dashboard contains the loaded data. It's ready. We are not plotting. We are not directly going for plotting, right? We get to see something on the screen. What are the various components that we see here is this. One thing is, right, the name of the file which you have connected, right? So this is the data source. Okay, so connection is on the left side, which says to which file you are connected. So this name and this name initially will be same. You can change this if you want. In purpose. Also, this will show you the preview of the data which has been loaded. So connection, when you establish a successful connection between the Tableau and a data source, right? It can be file, server, or whatever it is. Data is there now, right, with you, and it will show you these options, right? Again, these are the basic options which we will be seeing regularly. Other options do exist. We'll deal with that when we go to that. Okay, right, fine. So this is the connection. Connection is established, and you are able to see the connection name, right? You are able to see the what you call as a name given to that. You will be able to visualize a preview as well initially, right? This whole thing, right, what you see is called as the dashboard. Okay, fine. So remember the word dashboard. We are going to use it several times. Now, what are the various data types it supports, right? Because whenever I'm dealing with maybe a software, or I'm learning a new hardware, or I'm developing a hardware maybe, or a combination of hardware software, right? The flexibility comes into picture when I can say that it is very flexible, right? It should support wide range of data types, because what, because ultimately you are designing anything for the purpose of reading the data, processing the data, or handling the data, and converting the data into some other format, some other useful format, so that it can be used by a user. Okay, so now this is a software, right? let's say we are building the Tableau. We want this to be the most flexible one, right? So it means you have to, right, support each and every type of data format. If not, at least the most widely used, so that you can see that this is a very flexible tool, right, in terms of the handling of the various data types. Now, what are the various data types supported? Just see here, right? Again, you see these icons are important for us. That's why I'm not only just discussing about the data types, I'm also specifying what we will be seeing on the screen if at all, right, a data type is being mentioned. So if at all you see this icon anywhere, not, I'm not specifying at this location, anywhere, right, you see this means actually you are dealing with the text or the string, right? Maybe there is a let me assume that okay, I'll give an example. Let's say I have a Excel sheet. There are several in a file, Excel file, I have many sheets, say three different sheets. One of the sheet contains only text, means near the name of that particular sheet, you will see something like this. Just an example, okay? Like that. If at all you have a numerical or not numerical, sorry, data related value. So date means you see the second one will be able, you will be able to see the second icon. Date as well as time means this one. Okay, if you have only numerical, then you see the ash coming into the picture, right? I just gave an example of a particular sheet, but it's not necessary. You have a variable, name of the variable, something. Okay, that also it gives you that much detail. Anyway, we'll come to that at a different stage. Okay, so in addition to that, you can see that Boolean values are denoted by this, and the geographical values are also supported, right? Right. So you have geographical data. Okay, it understands that, okay, this you are talking about actually a country. It's not simple. India is not just a word. India is not an English name. India is actually a location on globe, right? It understands, so it supports geographical values. So what do you mean by that? How to handle, etc. We'll see that, okay, at a later stage. But just understand it. It knows what you mean by geographical value. Like time means what you understand. Okay, time means this. There is, right, there'll be hour, there'll be minutes, there'll be seconds, right? Second increases one by one, then minutes will increase, after that hours will increase, and so on. There is a date specific way, right? So what do you mean by date? You understand. Similarly, what do you mean by geographic? This Tableau understands. So you can see the various examples given for this. So Boolean means true or false. Date in this format. Date and time means you have a date followed by the time at which something happened, right? You want to stay that, we call it as a timestamp. In addition to that, we have the geolocations, right? Geographical values means when I say, see the words New York means I understand something. It's located at this part of the globe. Same thing, whenever if you are using the geographical value New York, then Tableau can map that New York to some location on a three-dimensional space. Okay, right. So then we have a text or a string, right? We know that numerical, decimal values, numerical, whole numbers, etc. They are supported, right? So these are the various data types what we have, right? What we see and what we use, right? Regularly whenever we are going to use the tab. Okay, then let's look at, again, this is a general way of representation, right? Whenever I open the dashboard, right, and I select a plotting option, right, I go one step ahead, not the previous where I showed the dashboard. This is the next step of the dashboard, right? In that, right, just I can specify, right, what I want to plot, right, before going for a plot, right? It opens up called something like as a sheet. So you can see a sheet here. Okay, so the sheet names, so this blue colored boundary what you see, we call that as a canvas. Okay, we are going to get the graphs over there, right? We will be visualizing the graphs over there, right, in the most fundamental fashion. Okay, whenever I say I want this versus this, x versus y, if I say that plot comes over there. Okay, now in order to specify x versus y means what you understand. Okay, x along x axis, y along y axis, I get a graph. So that means I need to specify x, I need to specify y. So row, column, correct? So that is slightly above that. If you see there, above this, I can see another dark blue color, this thing. It actually specifies rows versus columns, right? What x versus y in the simplest format of plot only I'm talking about. I'm not going to a very complicated graphical visualization. I'm not touching that. Okay, very simple. Let's start with. Later on, we'll do the what do you call the complex ones, right? So to start with, we'll be using the columns field for column data, which I want to plot row for the row data, right? So that's how it is. You call it as a row and the column shelf, right? Row shelf, column shelf, all together row column shelves. Okay, and on the top, the yellow colored boundary, whatever you see, that actually is the toolbar. Various tools are available over there. Okay, then what data I want to select? Again, this is related to the superstore data which I mentioned, right? I can see customer name, segment, order ID, order date, etc. You see that many things are available. Okay, on this date, what is the order? I can plot date versus order. One example, right? Like that, I can simply drag and drop something over here from the data plane. You can see that it is actually a data now. So data is present here. What I want to visualize, I can simply drag and drop so that I can visualize. That's how simple it is. That's why I told minimal programming is required whenever you are going to do the programming part. Most of the time, we will never do the programming. Okay, right. So that's one thing. So various sources, data sheets are available here. We call it as a workspace, and we have the data pane where you contain, which shows the complete data set, whichever has been loaded or connected to your Tableau, right? So to that, right, what are the what is connected, complete details, what are the various names of the variables are there, etc., will be visualized here. And then we have another part called as the marks card, right, using which you can actually select various types of the colors, the size, whatever is the label, right? Many options, right? That it's called as a marks, right? Whenever I have a mark tick on there, how do I change that? Size of your line width, right? Size of the text. Mark is X over there. I want to change the X to a star or something like that. Whatever you want, you can do that. Yeah. So again, this is the very fundamental view of the dashboard of the Tableau, right? After connecting to a particular file or server, right? So this comes up, and we'll be moving ahead with this. We can change, we can do a lot of modifications here. We can go ahead and we can get the sophisticated visualizations as well. Okay. So this is the basic desktop. Okay, desktop UI, user interface of the tablet. Now, before going ahead, we have to get familiarized with some of the terminologies. What are those terminologies? We will look at them one by one. So the first one which comes, so two terms which are going to come again and again. The first one is dimensions. Second one is a measure. Okay, so whenever we open a particular what you call, whenever we connect to a particular data, right, the source, right, uh, it will identify, the Tableau will identify, will categorize some of the variables as dimensions and some other variables into the measures. So what is the difference? So you see, this is how you can see that we are not doing that. It will be done automatically. So once we connect a data source, in the Tableau, columns will get divided into dimensions and measures. On what basis it is going to get divided, just understand that it becomes very simple. So dimension means what? It's a field that is independent variable. It can take any value. I think you understand independent, right? So independent variable is the one which you can select as your x-axis. For example, time, right? So something that is dependent on time is what you select on y-axis, such as velocity. V of t, you write velocity at a given point of time, isn't it? So that's why velocity is considered as a dependent variable and the x-axis is independent variable. Whichever is your independent variable, that will be right. So it actually, Tableau identifies that, and whichever values you can select as independent variable, it is going to put it into a category called as the dimensions. Okay, so you can see that it has separated few of them. Okay, and it also separates some other variables that are present in your data as measures. What do you mean by measure then? It is a dependent variable, right? In the sense, measures can be, right, plotted based on that category which you see in the dimension. In the sense, you see, so for example, right, I can look at the profit state-wise. So state is my x-axis, state number 1, 2, 3, 4. So profit I can change, correct? I cannot do the reverse plot. I cannot plot my what you call, right, profits over here. Profit is 1 rupee. Which state? How do you plot? Not possible, correct? So you see, it actually identifies that, right, by default. Easily it will do that. You don't have to struggle that. Otherwise, normally this happens with me, right? If the complete data set is given, I will spend a lot of time identifying what I need to take as X, what I need to take as Y. Okay, yeah, we have a question. Is there any way to select dependent and independent variable? No, it is just suggesting you. You don't have to select them. It is suggesting that facility is there is what I'm saying. Okay, so example I gave you, right? So I can plot the profit state-wise. So state becomes the independent variable, right? X-axis, you put the state, right? This state, this much profit. State number 2, this much profit. That's only is going to happen only when you select states along x-axis, right? So what do you mean by states along x-axis? State is a independent one, so that's why it is right in the dimensions category. That actually has been performed automatically by the Tableau. Okay, so hope that is clear. Any given data set, this will be done automatically. You don't have to worry about it, right? Selection is left to you. Which plot you will select, you have to select, right? You can select, give me state versus sales, give me order ID versus profit. You can do. It is left to you to whether you want to visualize that or not, you choose. But the thing is that it separates. By just looking at that, I can understand, okay, this versus this plot is possible. Right? This is very helpful because most of the time I spend a lot of, if I don't go for Tableau or if I just want to visualize something else by using coding, I always spend a lot of time deciding which versus what I have to plot, because I don't know, everything is not compatible. In the sense, sales versus profit, if you try to select, there is no meaning. You cannot plot it, right? So it's like that. Okay. What's the need of sorting out? What do you mean by that? It's necessary, right? Which one I can plot, I should know, right? I cannot plot randomly, right? Which is a dimension, right? That has to be selected along x-axis. I cannot swap it. That's the meaning. So you need to identify. Normally, we don't call it by these names, right? Tableau calls it by these names. Dimension means this, okay? Measure means this. This is the name given. But normally, whenever we go for a plot, right, we are doing the same thing. Recall any of the graphs which we had plotted, right, in the past. We had selected something along x-axis. We had selected something along y-axis. Category-wise, number of installs of app. Try to recall that. We had separated category-wise, right? family. These many apps are there, these many installed, out of which these are free, these are paid. Try to recall, right? EDA part, right? So that's what I'm talking about. You have to select appropriate x-axis, then only you are able to get a graph. That is a very fundamental thing in the data visualization. So it is actually helping you out by a huge margin, right? By separating them out. It says that, okay, whatever is there in dimension, you can select along x-axis. If it is not given, simply a list is given, means you will select randomly 2. Graph is not coming. Why? I don't know. Nobody knows why. What's the reason, right? Because data set is too huge, right? Data set is 1 lakh into 10 lakh columns, maybe. Who is able to go to each column and each thing row to check that whether it is possible, whether it is not possible to plot? No, you see, right? That's what is the necessity of this particular separation. I hope that is clear. Okay, so look at the definition. Dimension is a field which is independent variable. Measure is a field which is dependent variable. Its value is a function of one or more dimensions. In the sense, one can, if you choose x as a time, x as a distance, you can plot y. Y is a function of time, y is a function of distance, etc. You can plot that. That y axis is nothing but your measure. Okay, according to the nomenclature that is used by the tab. I hope that is clear. Right. Then there is another very important feature, very useful feature that is available on the first page itself. As soon as you bring the dashboard in place, right, we will see one small pane which is actually called as the show me pane. Okay, it's called as the show me pane. Right. So let us assume that I have selected, let me quickly move to the previous one. I have selected few few entries from the dimensions, and let me assume that I have selected few entries from the measures. Okay, few of them are selected, but I don't know what plot I can get easily, which is the best suitable plot. I have no idea, right? For that, the solution comes here, right? It is called as a show me pane, right? We'll see them in detail, but remember these terms, right? So the show me pane actually shows, right, for the selected entities or selected variables from my previous slide, that is dimensions and the measures. These are the possible plots. What you can see here, I can, as of now, I can distinguish a pie plot is possible. If I select that, a pie plot comes. Okay, I can see a geographical, this is geographic. Okay, I can see a stacked bar chart, right? Several types of bar charts, right? So you can see a box plot, right? And many things are there, right? So these are whatever the show me actually shows at that moment of time. Whenever you choose the various entries, right, from the dimensions and the measures, right, you simply have to select one of them to get the instantaneous plot of that. What are the possible plots for them also it will suggest. You don't have to worry, right? Whether a particular graph will come or not, you don't have to think, right? You don't have to write even code, right? That's why it is interactive. Simply select something that comes up. Okay, so this is again, anyway, you can decide later, right, whether you have to go with these set only or you want any modifications. How to do that, we'll come to that at a later stage. But as of now, right, just remember there is what is called as a show me pane that will come. You actually you see the screen that is there, that will be there always, right? You just have to select one of them if you want to go for a quick visualization of that. So if I select this and that is not clear, don't go for it anywhere else. Select another, double click on that, it will come. That is also not suitable. Select this. If at all you have to do the programming, you remember, right? So how much programs we have, right? So that is avoided here. Again, this is, we are still at the very basic level of what Tableau can do. Okay, right? It's still the basics, right? You may think that, okay, this is done by other softwares also. Why should I go for this? Yes, coming up. Okay, many things are there. which will come up at a later stage. Now we are starting, we are at the basics. Okay. Yes, Manish, do you have a doubt? Okay. Right. So some of the very basic, right? Very fundamental. Yes, Manish. Yes, sure. Previous one. Hmm. Okay. Hmm. No, no. One is on x-axis. What comes on x-axis is independent. Independent comes on the x-axis. Always. Not just related to Tableau or something. Any plot you go, what you plot along x-axis is there, right? That itself is called as independent. Okay. Depending on that variable, you plot something, right? My y-axis is displacement versus time, right? So time is horizontal axis, independent. Displacement is dependent. Displacement, so if I denote displacement as s, I will write s of t. Why it is s of t? Because s depends on time. Time is my horizontal axis. S of t is what? My y-axis. So at t equal to 1 second, displacement is 4 meters. At s equal to 2 seconds, displacement is 8 meters. You see, it takes only one value for a given time. So y-axis is dependent, x-axis is independent. Okay. Same thing holds good here. Only the names are different. That's all. Dimension is x-axis, measure is the y-axis. So measure is dependent on the x-axis. That is not necessary. It means independent variable is, that's what I told, it is general, right? So you go to physics, you go to maths, you go to any field, right? Independent variable is the one which you plot along. Okay, no need to specifically mention about that. Since it is mentioned that it is independent variable, that means it is x-axis. Okay. All right. Okay. Okay. All right. All right. Any other doubts? All right. Okay. So now we'll look at the various fundamental, what you call, visualizations, right? We have done this few times ago when we did the Matplotlib Seaborn visualization tool in Python. Okay. So very similar, right? Again, this is just an example. You have one option, right? If at all from that show me pane, if you select the bar graph, you will be able to see the bar graph. So this is a simple bar graph. Okay, what parameter, how to see, we'll see that. Okay, other than that, I can even select a line graph. There is a hybridization possible in the sense, right? Two things versus one thing. In the sense, you see that there are two graphs. One is a, right, red colored one, right? And one more is a bar graph, which you see here. So the y-axis values are different if you see. Right on the left side it says something, I think shopping cost. On the right hand side it's a different different measure, as you can see over here, right? So there are, you can do this is called as a dual axis graph, right? That is also supported. Again, slightly advanced than what we already know, but yes, right, we have many more things to learn inside the visualization part of the tab. Okay, so you can bring multiple types of graphs in the same visualization, and yes, you can bring multiple axes into picture, etc. Many things can be done, right? This is just a introduction to that. Okay, so that's one set of visualization. I'll show you another one, right? How it understands the geographical data, because there is a graph already present in that corresponding to the geography. Like for example, you can see here it's a US, right? The country map is there. So whenever you specify, right, maybe the state wise or the city wise, right, some data is being used, means that it actually identifies those locations. right, on a actual map, and it will bring the map and it will plot those points. Okay, so that's how the geographical values are mapped onto the practical geography, right? That's what, right? Again, how to do this, we'll see that later. And also you can, this is another example on the right side, what you see here, right? This is another example of the dual axis graph. I have two graphs coming up. So again, there are two values written, two different values written on the y-axis. Left side y-axis, there is something written. Right side, something else is written. Corresponding to this, you see, this is actually month-wise. Month-wise data is plotted. So month-wise, what is the sale and what is the profit, right? So that's what have been shown here. Okay, so if you want to measure the profit, you have to look at the right side y-axis. If you have to look at the sales, you have to look at the left side y-axis. So the colors are different for different plots, right? We can overlap, right, many things over here by bringing what is called as a dual axis graph. Okay, so that's one more very important feature, right? In addition to this, we can bring the heat map into picture, right? Just try to recall the heat map which we had used in the Seaborn Matplotlib, right? Libraries. Very similar to that, right? You can give color, right? For example, this plot was for profit, right? So you can see that wherever you have a profit value which is high, right? High profit values are actually, right, they are coming closer to the yellow, right, yellow color. If at all the color mentioned over there is more towards red, that means the profit is very less, actually it is loss. So there is on the right hand side, you can see that there is a scale given. On the rightmost side, it says that 129,585, so much of profit if you see that color. On the other side, red says that minus 29520. That means it's minus, so it's a loss. So now you can understand that, right? It's actually category wise heat map. Okay, so I can understand one thing from this is that if at all the category is tables under the furniture, if you look at the sales of the table, right, it is completely in loss, completely red color. There are some other categories vertically. That doesn't matter as of now. So we are simply trying to analyze a what is a heat map, right? Just making you to recall what we had done. So if at all I look at the, say, the phones, right, under the consumer category, you see that that is close to yellow. That says that okay, there is profit. So this is how you distinguish. Heat map is what is the particular name given to this kind of graph. By looking at a color, right, I'm able to capture the info because I don't want to worry about the numbers. I just want to see what category it is. Is it profit? Is it loss? Is it right? Something like that. That is easily possible by using this kind of heat maps. Okay. Then we also have what is called as a tree map, right? Again, it is another version. You can see the colors are given over there, right? And the according to the colors given there and also the size of the various shapes that you see here, that is going to give you the information about that particular category, right? So you can see that the highest profit is there for which category? It is for the copier category. Why? Because you can see the given color code for that. So as it turns out more and more towards the green, the number is 320417. So that's the profit amount. So for copiers, that color is given here, right? Indicates that, right, it's profit. So similarly, you can see that if the color comes closer to the blue region, then it is minus 64083. It's a negative, right, loss. So again, you can see the tables, right, fall under that particular category. Okay, the same heat map in a different way, they are going to call it as a tree map. Okay, we'll look at the details of this at a when we deal with the practical or the demo session. All right, let's move further. Just try to recall. Okay, so I'll go a little bit faster. Right, what is the best suitable? Yeah. Yes. Yes, Manish, please go ahead. No, no. As of now, just think that color-wise you are able to judge. Okay. So exact details, I'll go in detail when we handle. Because right now you don't have any idea about what data ID is what, right? So as of now, don't worry, right? Just think that color-wise, color coded, right? So some color means I'm able to understand. Yeah, here actually the size of the square, what you see is actually talking about something else. Okay, that feature is not there over there, right? So everything is same. Okay, width and the range is not changed. Which is the option? Yeah, that is tables. This one, right? This is tables. No, no. Actually, there is no difference. Both are conveying the same message, saying that tables loss. You have lost a lot of money when you sold the tables. Correct. No, no, no. That part I will come at a later stage. I'm just telling that these are the options available. Don't go in deep about visualization now itself because I'm not teaching you how to do this, right? I'm just saying that just look at this. These are the options available. That's all. How to do this? What does it mean? I'll come. Okay. We will teach that in detail when we do the demo. Okay, right. As of now, you just have to understand that, okay, there is an option called tree map. What the tree map does, tree map gives a color coded version of the information. What is the color code? You can see here. This color code says that anything which is coming closer to the dark green, that means it is a profit. Anything coming closer to the blue region that is present over here is a loss. So from this, as of now, I'm able to understand, yes, by selling tables, we lost money. By selling, right, what do you call, what's that? That's a couplers. By selling couplers, we made a lot of money. By selling phones also, it's a profit because it is coming very closer to dark green. So these are moderately, right, profitable. As you come to this part, right, so you have lost, right? It may not be a proper loss, okay, but this is complete loss. Only that much we will be able to understand. Okay, I hope that is clear. Okay, all right, sure. So, okay, it's a time for a break. Do we have any other questions? Any question, please feel free to ask. Uh, those who don't have any doubt can go for a no. Let us look at the various visualizations and when we are going to use what type of visualization, right? This is a something like a convention, right? That doesn't mean that you have to use for this case only this graph. Definitely, you can use other graphs as well. Okay, this is something like best matches. That's all. So, for example, bar graph. If you consider the bar graph, right? Whenever the dimension is discontinuous, right? Whenever dimension is like right, 1, 2, 3, 4, right? And for one, I have some value, two, some value, no values in the middle. Such cases, you go for bar. All right. So that's what we know, right? Whenever we have such a scenario, we will be using them, right? So most of these points are pretty much clear and we know them. Whatever is new, we may have to discuss it later. Okay. Now, if at all you have a continuous dimension, then the graph becomes continuous, right? So that's why it is a line graph. So the second point says that I'm going to use a line graph, right? Whenever the preferred, right, that the dimension is continuous, right? Then you can, right, go for a line graph. If at all you want to measure or represent various parameters together, right, then you go for a dual axis graph. So dual axis graph, one of the example I have already shown you, right, in one of the previous slides. You can measure the cost and the profit for every month, right? So that can be one example. Then the geographical graph is, right, you will go for location and something you want to measure and something you want to plot, right? We will be it's preferred to go for the geographical. Then there is the area of graph, that also a dual axis, right? uh, it's again for comparison, right? So dual axis are always for comparison. Then the heat map, right, visualize the variation of the categories, right? If you have nested visualization, we will use the tree map. Okay, right. So detailed view and right, detailed implementation is going to come, right, at a later stage towards the end of our module. Okay, so now the next important aspect is that there are several functions that are supported in the tab. So this is another difference compared to other plotting tools. You have the features, right, such as the functions that are not supported in any other plotting tools are supported in the tab. Okay, so let us quickly go through them and let's try to understand what do you mean by functions and how they are used in tab. Again, this is overall overview, that's all. Okay, how to implement that we will be seeing that at a later stage. So in SQL, we have seen the join as well as the union. Now you see, if I am bringing the data from various servers, if at all you are using the query languages, yes, you know that you can, right, perform the operations such as join, union to get the results, right? In the sense to get a combined results. But now you see, I'm connecting to SQL server, but I'm not writing a query over here. So I'm connecting to any server or multiple servers and I'm bringing the data. And once you bring the data, if they are in various what you call forms, right? I can join and I can either join or I can do the view. So just try to recall. As you can see here, the difference is very clear. Join is something, right? I'm concatenating row wise. I have a data here, I have another data here. If you simply, right, concatenate one after the other row wise, in the sense rows are kept constant, number of columns increase. That is what is the join operation is going to perform. Right? Very simple. This is what we have discussed. Try to recall. At the same time, there is another operation that is called as a union. Right? This is vertical concatenation. I have a data here. I have another data here. I am actually concatenating one below the other. That's all. Right? So you can see here, right? Color wise, you can actually differentiate. Number of rows should be same. Okay, in order to, yes, that's right. So in order to perform a join, right, we have a condition that number of rows should be same, then only I can attach, right? So one has 5 rows, second has 4 rows, you cannot attach, it has to have 5. So 5 here, 5 here, you can attach. That operation is what is called as a join operation. Okay, so join is that same operation you do vertically, name it differently, that's all. It is given a name as union, that's all. Okay, so I have 5 columns, another one with 5 columns, simply attach one below the other, you call it as, right, the union. Okay, names are different, but just the names are given differently so that you don't get confused, that's all. Right, so you understand join means this is how it is done, uh, union means this is how it is done. Easy to recall, that's why the names are given in that particular fashion. Is it okay? I hope that is clear. Yes, right, let's move further. Yes, Manish. It's like row wise, it's the same data. Columns are different. Let us assume. Okay. Something like maybe the first row is mobile phone, second row is table. Okay. But the columns are different. I collected the data corresponding to mobile phone and table. Okay. Mobile phone and table. But the columns are different. Initially, I just had a cost. Okay. Now I have number of production. Right? Where do you add? You have to add horizontally only, right? So one column I already have. I have to bring the next column. I cannot make it vertically, right? Because the the product I'm looking at is still mobile phone and tables only, right? It means the rows remain same. I simply attach the new and new columns. That means what? You are performing the join. Okay. When the columns remain same, I keep attaching more and more rows to that. Correct? It means I already have four columns. I am looking for four different columns. Okay. Like maybe I'm trying to look at the price of houses, right? I keep the columns same, right? The area, square foot, number of beds, bedrooms, and something else. Maybe four columns are same. Property number one, right? That is first row. Property number two, second row. I saw three more properties at three different locations. They will come below them, right? Because property three, four, five. See, I'm actually doing the right, attaching them to the in a row wise form. So I'm adding the rows. Columns are same. So that is what is unique. So how do you decide? Now you understand. Correct? Yes, yes, yes. Any other doubt? And Gaurav asks, join works with the rows only. It's actually when you perform the row wise, it is called join. Okay. So I cannot perform, I cannot do another method and I cannot call it as join. Okay. Yes, yes. Hmm, hmm, hmm. Okay. Yes, yes. Hmm. Yes, yes, correct. Because you are attaching more and more rows. Okay. Number of columns fixed, rows are increasing. Correct. Yes, yes, true. Columns. Rows are there, columns are increased, join. Perfect. Yes, yes, yes. Perfect. Okay. Yes. So this pictorial representation you try to remember whenever you think about join and you. Okay. Similar operations we had carried out in case of the SQL. All right. Yes. Let's move ahead. Then we have another very important function, that is a sort, right? So what sort is? We know that you can use the sort for maybe a category, subcategory, depending upon the values or the measure, right? You can actually, right, perform the increasing way, decreasing way, etc. are possible. Again, one of them I have shown here, right? How exactly to do this? We'll see that at a later stage. Okay. So we have another question. Can join work if one table has five columns and another table has six columns? What do you think? What do you think? You just look at this diagram and can you answer that? What do you think? Will it work? It will work, right? So join should work because I'm increasing the number of columns itself. So when I'm increasing the columns, it doesn't matter how many columns. Number of rows should be fixed. Okay, right. So same answer holds good for the union. As far as you are increasing the number of rows, number of row counts do not matter, right? Column should be same. That's all. Okay, all right, yes. So the next function is sort. You have an option to sort it out, increasing, decreasing order as per the requirement. That just gives a more clarity of the visualization becomes more neat. That's all. Okay, so that is one option, and you even have the option to sort it if you have subcategory, right? This is one function. Just remember there is what is called as a sorting. How to do this we'll see later. Okay, then we have an option called set. It's actually a type of filter. So what do you mean by filter? I have a data set. If I apply a filter on my data set, I select certain data points from the complete data set which satisfy some condition. Okay, so same thing is being applied, right? So just right, don't worry about the graph or something, right? So we have, right, what is called as a set being defined, which is a filter. On my data set, I can define something like this. Okay, I can define something called as a set, and I can specify certain condition. What's the condition here? You can see that it is greater than 10%, right? In the sense, plot me something specific plot I'm going to call, but before that I'm asking I'm trying to apply a filter. Whichever data point satisfy this condition, right? All the objects, right, satisfying all the items which satisfy this condition, right, can be sorry, will be plotted over there, right? So here you can see that this was the condition, right, irrespective of other parameters. So other parameters could be something like, you can see many things are there. So like first class, same day, right? Second class, right? Year wise, 2012, 13. So many things are there. Many other parameters are there. That is according to the given date. Don't worry about that, right? So these many, right, values have satisfied this condition. That's why they are being plotted. Okay, so remember that what do you mean by set? It is a type of filter. There are other filters also. They fall under the filter category. There is a slightly different one which is called as a set. Right? You can use a set as a condition for displaying the value. All right. Then there is another function that is called as a forecasting. Right. This is used to predict the trend, right? What is going to happen in future, right? Let us assume that you have the data, right, corresponding to the years 2012, 13, 14, and 15. Now you ask the Tableau to predict what will happen in 2016. That's what is happened here. You can see 2016 has been actually highlighted just to show that this is the prediction, right? That data we don't have, but simply it is predicting that is dependent on the past values, right? So that is another feature that is available in this Tableau, which most of the other plotting tools do not have. You have to fit, like you have to perform either machine learning, apply some fundamental data modeling techniques, right? Only after that you will be able to get the result that you need to call another plotting functions to plot, right? So as you can see here, see here, it can be predicted here. So we have a question: is forecasting is like predicting the price of the share, right? So this exactly, you are not trying to predict here. You are trying to predict the trend only, right? Whether it is going to increase, decrease, you can do that here. Okay, so for a prediction of the price of a what you call share or something, you will perform the regression, right? So there are various regression techniques available, right? We'll be performing that. But here internally it is going to perform a regression, but I don't have any option to select that I need only this method, do a linear regression, logistic regression, etc. I don't have an option. But I can ask it to make a forecast and say that what will be the trend. You see that the 2016 actually shows a trend like it is going to increase. In the middle it may decrease, doesn't matter. Compared to the initial and the final value, you can see that there is a increase. So this trend can be forecasted. So that's what has been mentioned here. Forecasting is used to predict the future trend, only the trend. Whatever value, it will definitely show some values, okay, but you cannot say that the value on say September will be 2000 rupees. You cannot say that, but it will simply do that. So you just have to tell that do a forecasting. Yes, it will do that automatically. Okay. All right. So that's the next function that is called as a forecasting. So forecasting of whatever data that will happen in future, right? Whatever might happen in future, you can do the forecasting, provided you have the past data, like 2012, 13, 14, 15, right? Using whatever past data you have, you can ask uh, this to make what you call as a forecast. All right. Then the next function is called as highlight. I have many subcategories corresponding to a graph, and I want to highlight a specific product maybe, right? I want to highlight a specific product, right? So everything will be plotted. Only the one which you ask to highlight will be brought in dark color so that you can compare, right? So all others will give you the general representation. The specific one can be highlighted. So multiple highlights are also possible, but when you highlight multiple things, there is no meaning for that. So it is suggested to keep only one highlight, others are in the same. Okay, so that is also another way. By just click doing drag and drop procedure, you can get this. Normally, if you use any Python libraries for doing such plots, right, it will take several lines of codes, right? You have to write so many lines of codes to do that. Okay, so you can see that, right? Highlighting is also pretty useful and used for highlight the specific subcategory, right, among all others. Many things you have, you want to highlight a specific thing. Yes, you can go ahead with what is called as highlighting function. Right. Then this is pretty much important. I find this is very useful. Whenever, depending upon what device you are going to visualize this, because see the normal thing is like I have my data set, right? It's a business related data, right? So normally this is built for business intelligence. So what you do, you have data, you don't have to give this data to everyone whom you are going to do the business with, or you have some clients. You want to show your the company's performance, okay, to by sending a mail and by attaching this to a mail or something. That's it. So under such case, it is not necessary that you have to send the complete data to the client and tell them that, okay, do this visualization, you will see this. It is not required. Sorry. So whenever we go for a visualization, sorry, just a second. Sorry. Whenever we go for the visualization using Tableau, whatever dashboard you have, you can save it, and the saved snapshot can be converted into any of the format and you can actually send it. Okay, so that's the fundamental. Now, when you do that, the visualization should be right. In a sense, if you want it to be very good, very vibrant colors, whatever you have chosen, etc., should be capable of displaying for the full extent for the device in which you want to see visualize that, because we have different types of what you call devices present, right? So for each of the device, resolution is different, so the color range is different, etc. You have a lot of options there. So specific to a device in which your client is going to visualize, they may have a 4K screen, they may have so and so resolution, they may have so many colors, color depth, many options you have, right? So when you do this visualization, it is possible to specify the device, what type of device it is, what model it is, right? You can see on the top, I have highlighted with the red color. There are few options visible here, right? One is a device preview, device type, selected tablet, right? What is the model? Generic tablet 1024 into 768. So this is actually the resolution which we are specifying, right? And if you are using the same device again and again, right? If you are dealing with a client who is going to have the same device for visualization, you can save that device as well. So every time you don't have to create a new this thing, right? Simply select that device, it will get saved in that particular format. So you see, this is very helpful, right? Because business, in the sense, you have to make sure that, right, you help them out in, you say that, okay, whatever you do, it should be right, they should be happy with that. Okay, so they should visualize it with very clarity on their screen, right? So my tab is this big, and if my plot is very small, I'll say what type of plot it is, I don't understand. So you have that option. Okay. Yeah, Deepak, thank you. Yes, yes, any doubt? Yes, I'll repeat. No problem. I will repeat. Let's say, right? So two types of screen. Let's say I have. One is my normal laptop screen, which is 1080p, like the normal HD screen. Let me assume I also have another screen which is 4K screen, high resolution, right? So depending upon where you are going to see, right, you can, right, specify that, okay, save me with this size. Very simple. Okay, save me this particular visualization so that I can visualize on a 4K screen. Just select that particular device, right? If you know the device name, otherwise select the resolution and you can save it. So that when I visualize the same thing on my 4K screen, it looks properly fitted, because 4K screen is larger, right? If I visualize that simply HD on a 4K, it will be small. Otherwise, you see that simple HD 720p. If you visualize that on a HD screen, it occupies a portion of your screen. Correct? Isn't it? So that is what is meant by device design, used to make best visualization specific to your device. If my mobile phone does not satisfy 720p, it's just 480. What you can do, you can save it. That saves memory as well. Okay, so it's actually, it's a business view, right? Those who have high resolution device, costly device, they expect quality. When you show something to them, they expect very good quality, right? So that feature is also there. You can save it with a specific resolution specific to a device. Okay, only that's the option. Additional option which is there in uh, this Tableau, right, which we don't find in any other visualization. I hope that is clear. Manish, any doubt? Hmm. No, in the screen I cannot show anything. I don't have any option. Right? So I'm not running any this thing right now. So yeah, I can just think that I'm changing the resolution. Then according to the display of your device. You have a mobile phone. I want to send this image to you. Means what I do, I will select the appropriate resolution of your mobile rather than selecting my device, so that it best suits to your screen resolution when you visualize this image. That's all. Okay, only that's the case. Not a very high and not a very high complicated calculation. Nothing is done. Simply select your, I simply ask what is your phone, maybe, right? You will say iPhone. I'll see what is the resolution of iPhone 12. I just find it out in this. I'll save it. That's all. Very simple. Okay, so that when you see, you will be happy. Okay, yeah, this is very good. You will just say that. That's the motto. All right. Okay, so that's the device designer. All right, then let's move further. The visual analysis part, and right, what are the various steps in a visual analysis? Initially, we saw that various components in the visual analysis. Now we are going to look at the step-by-step procedure in which the visual analysis comes into picture. Again, this particular topic is very important when you do the business analytics. Okay, so in the data science, once you learn the basics such as machine learning, deep learning, right, scalable machine learning, and maybe the neural networks, etc. Once you finish everything, where you are going to apply that ultimately is one such vertical is the business analytics, right? So majority of this data analysis falls under the specific case of business analytics only, right? So how to improve your business, take a past data, past 10-year data, and right, come up with a solution so that you can improve your revenue, you can improve your what do you call total turnover, you can increase you want to increase your profit, reduce the losses, costs, etc. So that's the ultimate idea. Everything is right, whatever you study, right, in all these cases should be applied somewhere, right? So that one such part is what is called as the business analytics, business intelligence, and under that, this is the very one of the very important, right, where you have to you will present to your client saying that I have this much experience, like my company has, right, done these projects, right, this is what we have done, etc. When you show that, right, what is very important is this visual analysis. You cannot plot complete table and keep explaining that will never help. Visual analysis needs to be performed. Look at your data, get the best out of it, get the best graphs out of that, and then show you that's what is basically expected. So in order to do that, right, the whole procedure is called as visual analysis. I already had shown you one slide earlier, right? Now the steps needs to be followed, which is what is supposed to be implemented whenever you are using this particular tool. Okay, so we start with the acquire part. So as we already know, this acquire part is collection of your data, right? You have many resources available, right? Many forms available, right? Whichever is the easiest one for you to collect, because budget also comes into picture, right? I cannot keep wasting money on simply collecting my data set or preserving my data set. So you have to do a balancing. I collect most of my data, I don't lose the most important information. At the same time, I cannot keep wasting a huge amount of money on a server, right? So that's all. So acquiring is important. Then you go for a filtering. You filter out, right, whichever is needed, whichever is not needed, you decide, right? You have the uh, full control on what is required, okay, right? So filter it out, we know filtering process. Then the enhancement, right? Enhancement in the sense whatever is important you can boost it. For example, image, I can give a better example. I'm interested in a specific part of the image, you enhance the image, right? It's like, okay, then you can go for a fine tuning, right? Then you deliver. So after fine tuning, right, you deliver the visually available data. So plotting can be used at any point here. So acquire, I plot, I see that okay, this data is not good, I filter it out, once again I plot. So plotting is there in every aspect of this particular cycle. Okay, so acquire, you plot, you see something which is not good, filter it out, once again plot, you see it's not good, enhance, visualize, then something has to be modified, tune it, once again visualize. Yes, everything is fine means you deliver. So that's how, right, deliver in the sense you present, right? So before you go for a presentation or with a client in a business meeting, it is expected that visual analysis has to be performed using this particular case. Okay, this is the general cycle. Again, some of the steps can be skipped. Now, what is the importance of visual perception? I'm going to give a very quick demo now. I have a question for you. Please use the chat box to answer. All right, right. I'm asking you to count the number of fives over here. How many digit five you see? Right, count and enter. Okay, not more than 1 minute. We have many more slides to cover. So this is an exercise, plus I want to highlight something here. what happens? So here I don't have any what do you call proper visual representation, because what I'm asking, right, it's something like a random. Somebody might have asked you to count the number of nines also, right? So, but I'm asking five specifically because I'm ready with the answer for five only. I don't know how many nines are. Okay, we have one answer from Somesh, 18, Swati, 17, Gaurav, 20. Okay, Upkar saying 18. Okay, Rohan says 19. Good. Others, everyone please try. Whoever is attempting, I appreciate your efforts. Others, please go ahead. Okay, Swapnil, 18. Priyankar saying 19. All right, Swapnil saying it as 18. Okay, fine. Okay, so this particular question, what I asked, falls under a specific type of visual perception. It is called as attentive. Okay, so you need attention to get the information from that. You need to put some effort. So, like what you did. Okay, I'll wait for say 30 more seconds so that whoever has not answered and who is still counting, please put your answers in the chat. Okay, so remember, whenever the whoever is the intended person who is going to use your uh, whatever you show as a visualization, whoever is supposed to gather an information from what visualization you show, right? If right, that person has to put some effort, right? Put some attention, right, to your visualization to get the information from, right? This is called as a attentive. Now you see, you all have are doing things. I'm showing you some, right? But in order to get the information from that, you have to do a lot of what do you call, right? Effort, right? Attentive means that. All right. So, okay, others, no answer. Okay, I'll move ahead. No problem. Now I ask the question, right? Count the number of fives, right? You please go ahead and you can change your answers. All right. This is called as a pre-attentive, right? Already what information I wanted to convey, right? I have highlighted. Okay. So this is pre-attentive. Attention has already been given to that so that the intention or whatever information that I wanted to convey you, right? I'm helping you out, right? By highlighting, right? So, yes, 18, right? Okay, good. Right. So, right, two different types of visual perception, right, do exist, right? Many more types are there, but very important are these two, right? One which makes people to put an effort. I show you a graph, but doesn't make any, doesn't help anyone. They have to put some effort, and then after doing a lot of analysis, they will understand, okay, this is what he's trying to say, right? The second one is, right, whatever I am, whatever plot I'm using here or whatever visualization I'm using here, right? In addition to bringing up the visualization, bringing up the colors, bringing up the graphs, right? What I try to do is I actually try to highlight the actual information. I'll try to select appropriate graph, first point, that is necessary. Second thing, I'll try to highlight something over there so that the actual information is conveyed as soon as somebody is going to look at that, right? So at least 50% you can actually save others time, right? You can make others to put less efforts, right, in understanding what you are, what you are intended to convey, right? So this is what is important. So always go for pre-attentive, right, where people will definitely appreciate, right, what you are trying to convey in that case. Okay, I'll give another example, right? So just see here. So there are three different year-wise data, and the data has been plotted in the form of a pie chart. And maybe, right, I can ask a question such as which year the third, I can ask the, yeah, third quarter, right, of which year uh, gives you the highest profit. Let me assume this is a profit data. I'm not very sure what data has been used for plotting. Okay, so area of the each of the region talks about the amount, right, or the weightage. Whichever is highest is what I want to look at that. So everything pretty much looks similar. Maybe if you look at very detail, yes, that's what this falls under, right, the attentive case, because it is not pre-attentive, because everything looks very similar. Yes, I can see answers coming up 2014, right? If you look carefully, after you put some effort, yes, you can answer that. Okay, right? So yes, I think even I didn't observe this. Yeah, so 2014 looks like a having a bigger area, right? Okay, fine. So mostly that is the answer. But instead of this pie chart, right, which is a plot that might have been used here, so that that conveys the message loud and clear. Okay, so let's see that. Okay, yes, I think your answer is right, 2014. So that answer is actually present over here, right? So this is the largest, okay, and that is 2014, right? So you see the pre-attentive looks something like this. Okay, so just a difference, just to bring up the differences, I'm trying to show various graphs here. So when we go for the graphs, it's not that everything is available for us at the tip of our hands. Like, so the Tableau is going to make things very easy for you to, while bringing various types of graphs. But graphs are available. What's the use if you go something like this, right? I have to think and I have to go with the proper one, such as this. Now you see this actually gives, even if I change the question, yes, you have an answer, right? In the first quarter, right? Which year? So that actually I can see that, okay, the pink color, so that should be 2015. I can ask, even if the question is changed, yes, you can visualize that clearly and you will be able to answer that. Okay, so like that, right, this kind of graphs, whatever you get, right, that fall under the pre-attentive. Okay, you try to make things easier for whoever is going to visualize, whoever is going to see your plots of the visualization. Okay, any doubt with these concepts? Okay, that's good. Let's quickly move to the next part, that is the Tableau product funnel. Yes, Manish. This one? Okay. Yes, sure. Okay. No, no, no. No, no, no. This is not Tableau specific. This is general, right? Whenever you go for a visualization, whenever you are preparing some graph, I'm suggesting there are two types. One, you simply plot something, but nobody is able to get anything out of it. They have to do little bit of work to understand. such as this question. I asked number of fives. You actually had to struggle to get the number of fives here, because I don't see where is five first of all. I have to locate, then I'll do that, then I'll get the information. This is one method called as attentive. Graphs can be attentive, graphs can be pre-attentive. Like this, you highlight what you are conveying. What I want to convey, there are so many fives here, is what I am conveying you. That means I highlight them, right? So that is called as pre-attentive. Tableau is not going to help you in any of this. Tableau will simply plot it. Okay, whatever you ask, it will plot. You have to make sure that whatever you want to convey, you ask Tableau to highlight. If you say highlight something like this, it will definitely highlight, but it will not highlight automatically, no question of. Okay, it's simply you give instruction, it will follow. Yes. Yeah, same thing, same. See what? Yeah, sorry. Yeah, correct. No, exact data, I'm not aware. What data has been used, I'm not aware in this case. But I want to convey a message that instead of plotting the uh, pie chart, you should go for what is called as this kind of graph, the bar graphs here. Because my question was, it's clear, right? I may ask a question, right? In which particular year the third quarter gave you most of the profit, right? Maybe if you look very carefully, you are able to say that 2014, because most of you have answered 2014 by observing it carefully. Okay, right? So if at all you went for this itself, here itself you can see that, right? This color stands for which one? 2014. So I am able to answer that easy. That's my intention. My intention is not to look at what value it is. I'm just trying to say that these are the options available, right? Not only in Tableau, in any other visualization tool. Okay, you will convey the message easily if you select a appropriate graph. That's what is the point. Maybe there is other graph which tells something in more easier fashion than this. Okay, go for that. That's what is the point. No, 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 no. Only for this case I am telling. Whenever you have very close data like this, right? So see this. They are very close, right? Everything looks very similar, right? So you have to look at your data. Appropriate graph you have to choose is the ultimate point. I'm not saying that don't go for pi, always go for a bar. No, there may be some cases where bar shows you, right, confusing way, and the pi gives you a more clear way. Possible, right? But you have to explore that. That's what is my point, right? You have the two types of graphs ultimately. One is attentive, one is pre-attentive. Always go with the pre-attentive, which gives you a more clear idea about what you are trying to tell, what you are trying to convey to others, whoever is going to see your graph. Is the ultimate point. Is that okay? Right, sure. Let's move ahead, and now we'll move to the various products that are present in the Tableau family. So as I told, Tableau is a company, right? It is not just producing one product called Tableau. It actually manufactures many other tools as well, right? It falls under the same category called Tableau. Okay. So the first one I would like to discuss is what is called as a Tableau server. Anyway, this is a free version. You already all know this. I'll come to that later. So when I use it, right, everything is under the same hood. It is called as a Tableau desktop. You are using it on a computer. It's a Tableau desktop. But what is the type of the tool that you are going to use if you are connecting? Uh, if you are running the Tableau for your complete enterprise, like I have a big office, I have so many people working, I have, right, so many visualization coming up because of a huge data set related to a big data which my company works on, right? You will have to select, right, in order to handle that much, in order to handle that much data, you should have a huge capacity that is supported by the Tableau server. It's a version, that's all. Okay. Next one is Tableau Online. As the name suggests, if you get an online license, there is a server which is running on the Tableau site, right? You don't have to install, simply you can use it. Okay, that online version is also possible. Then you have a Tableau reader. If you remember earlier, I mentioned about a reader. This is the same reader. What this is going to do, this is going to perform. So you will what you call, you will generate a visualization and you will keep it in a format such a way that somebody can read it, like something very similar to the PDF, only read only form, right? So you send this to someone. If they have a Tableau reader with them, they can actually visualize that. So that's another product under the Tableau. And then the most common one widely used is Tableau Public. Okay, so Tableau Public is the one which is freely available, right, with the limited capabilities. But in order to understand the usage of the software, okay, this is more than enough. Okay, or until and unless I have very specific requirement, uh, I will not go for the Tableau server or online, which are the paid versions, and you have to pay a lot for the licenses. Okay, so this is the product family. Now let us look at the pros, what we have here. The first one is ease of use, right? Already I mentioned about the ease of use, in the sense any type of data you have, anywhere it is stored, any format, any file, right? Any server, right? Most of them are supported, right? You can directly bring it and you can start working, right? So the same thing is mentioned in a different way: direct connect and go. You can connect to that particular database, file, etc., bring the data, and you can, right, have a visualization, right? And the perfect mashup in the sense it's actually dealing with all the functions, right? Whatever functions we had discussed earlier, right? You can have two different pieces, you can club them, you can join, union, do a lot of operations over there using the functions. That's what is a perfect mashup stand for, right? You can, right, mix up, example, best practices in the box, right? It is in the sense whatever the business analytics requires, everything is there in that. Okay, because since we have not touched the business analytics part over there, we may not have a clear cut idea about that, but still, yes, right, the Tableau is the one in the top five since last, maybe last 6 to 8 years. It's still in the top. Okay, there is a lot of competition happening between the Microsoft Power BI and this Tableau, right? It keeps going, right? There's a lot of competition, and it's for the good, right? So uh, half of the year they are on the top, half of the year Tableau comes up again. They will, so version changes means uh, there's a lot of things happening, but still only those who are at the very top. What uh, I have observed in the last at least 5 6 years. Okay, so we'll move further, right? Again, this is just a recall of what we have discussed so far. We'll go quickly, right? Because since we don't have much time, I may not be able to start with the demo session today itself. We'll definitely move on to that in the tomorrow session. Okay. Yeah, we have a question before that. Can we do filtering of the data, like replacing missing columns, stuff like that in it? Yes, you can. Okay. So connecting to data, as you know, right? The first step is you have to connect. You can see the left side option. What are the various connections possible, right? So there is, right, which I have not shown earlier. You can see here, data connection is something like there is a connect live option, right? So connect directly to your data, right? In the sense, speed of your data, which format you have stored, and what exactly is happening with the data is going to decide the performance. That's what is the connect to live. So other two options are import all data. Everything will come to the computer memory and it will be processed over there. So all data will come to the Tableau's, right, data entry. In the sense, how much memory you have allocated for Tableau, it will be taken up. Then the import some part of the data, it's a sub part of your data will be coming into the computer memory, right? As and when required, there is data exchange that will be happening. Okay, so those are the options over here. So connect live, import all data, import some data. These are the options you have, right? Then normal thing, join. So this gives a very clear cut idea about the join. Try to recall what we had discussed in SQL. One is the left join, right? There are two tables, right? Whenever I'm trying to do the join, I can keep everything, right, from one of the left side table, and I can also keep the whatever is in the common between the two tables, A and B, something like that. You can see whatever is in the dark color is the result, right? So left join takes out the common thing between A and B and complete A, whatever is there in A, right? So right join does the same thing for the right side table. Okay, whatever is common between A and B, that will be used, plus every element in B also will be retained, right? So that's what we call as the right join. So left join is over, right join is over. Then we have what is called as the inner join, which is the something very similar to intersection of your sets, right? I have two different, maybe two different data sets, right? I can retain only something which is common, right? So that's the other join. And full outer join or a simple outer join means everything you can keep, club them together and keep it. Okay. So again, try to represent this in a very easier pictorial fashion. That's all. Okay. So nothing to do with the Venn diagram or something. Don't think in that way. Then the next one is the show me, right? Already we have discussed about this once. So what this show me does, you have select some parameters, right? Uh, Dimensions and measures. When you select them, this tells what are the possible options you have for the selected variable, selected dimensions and the measures, what you can plot, right? So you can see here various plot options are available here. Out of them you can choose. So you can see that these are not they're not highlighted. So these are highlighted 1, 2, 3, 4, 5, 6, 7, 8, 9. This is highlighted. Next, this is highlighted. In the sense, these are not available. You can understand. Okay, like that. So whatever is available, it will highlight. It will show in a with a darker theme, right, or a bright theme. Right? Others will be simply right disabled. Right. So whatever is enabled, you can actually click on that so that that visualization comes. So this is very handy, right? I find this particular feature is very interesting because which one to be plotted, how should I go about, etc. You don't have to think, right? Simply select that and it will plot. Okay, so we have a question from Deepak. Data show me automatic give hints what we can do in terms of graph with the given data. Yes, so this is actually something like a hint itself, right? You can plot all these graphs from your given data. Okay, from the given data set, whatever you have, right? You have option to plot these all graphs, right? So this is what it is trying to give an option in a very quick fashion. You don't have to keep searching everything over there. Simply see that, okay, whatever is highlighted here, right? Only those graphs can be plotted from your data set which you have selected. Okay, very straightforward, very easy, and you will also find this very helpful. Okay. All right, let's move further. Yes, Manish, please go ahead. Previous slide. Okay, so there are two circles. Consider one circle is represented as your data A. Another circle represents your data B. Okay, so you may have some rows are common, right, between those two, right? You want to retain the complete data set A, and whatever is common between A and B means you will perform what is called as a left join, right? If you still have doubt, I suggest you to go back to the SQL notes which I had given you. There you find the complete details about this. Okay, but I'll brief out the answers, no problem. There is another option, like I want to keep everything from B plus whatever is common between A and B. Right? That means I have to perform an operation called as a right join. You can see everything on the B is dark, right? And everything that is common between A and B also dark. Okay, so this operation is what we call as the right join. Right. There is another kind of joining which is called as the inner join. As the name suggests, inner join in the sense the common, right? Common data points comparing, while when you compare A and B, both data sets, whatever is common, only those values will be retained after the join. Okay, so if I say C is equal to A inner join B, whatever is common between A and B will be moved to C. This is what is the point. Okay, and there is another term called as outer join. It's also called as full join or full outer join. That means A and B means completely club A and B. Everything is in A, everything in B will be your answer when you perform full outer join. Is it okay? Right. So details are given. More detailed version of this answer you can find in the SQL notes which I had provided earlier. Okay. Any other doubt? Next slide. Yes. Yeah. Show me something like you have selected some of the parameters from your data set. What graphs you can plot? It is suggesting you can suggest all you can plot any of these graphs is what it is saying. It is left to you to choose this or go for any other graph. It's a suggestion. Okay, Tableau will suggest you can go for these graphs. All right. Okay. All right, then let's move further. Then the next thing is a hierarchy, right? So hierarchy is actually uh, I have my data set with me. I want to look at my data set in what you call as starting from high level. I want to go right step by step, deeper and right. So that is what is hierarchy, right? So hierarchical design means you start from the top, go one step below, design the sub components. So each of the sub component can be further subdivided and you can go in depth. That's what is a design process of, right? A design process involved, which is called as a hierarchical design of anything, software, hardware, circuits, automotives, anything. Each and everything will have these kind of design procedures. Same thing is applicable, right? Whenever you use hierarchy, right? You can start with the high level overview of your data. Like I look from the top. Assume that I have data points here. I look from the top. I identify that there are some categories. So that's why the category is written over here. That's what I visualize from the top. Okay, right? So maybe, right, I can see maybe Amazon data set. If you see, right, you will see various categories: household items, electronic items, right, etc. Those are the categories. Once you go one step in that, right, inside the electronic category, you see there are many subcategories. So that's what is written below that. You may have, right, one category or many categories over there. So subcategories, right? This can be further divided, but anyway, I have not shown that, right? But just understand, hierarchy is that, right? Move from the top, go one step below and visualize that, right? Once I visualize that, I find that there are many subcategories. I go to one of the subcategory. Inside that, I will find out something, right? Like that. This kind of visualization is, right, called as hierarchical visualization. So you use what is called as hierarchies that is present inside our tab. Okay, this is one very important concept, right? We'll be looking at that everything we discuss will be discussing in detail at a later stage. Today's class you can consider as a complete introduction. Okay, then the a very important feature is groups, right? I have my data set available, right? I can try to form groups among them, right? It is something like there are many subjects, right? And you have marks, right? Subjects and marks are is what I have. My data set is subjects, marks. What groups I can make here? Class wise, right? Like if you have subject and marks for say every student that is present for maybe class 5 to class 7, let's say, right? I have that. What I can do, I can make a group of class 5, a group, class 6, another group, class 7, another group, right? So that is what is called as grouping, right? It will help you in uh, gathering some information, right? Grouping is optional, but sometimes it's going to give you uh, some information related to uh, the data set, right? So this is option, right? So the hierarchy which we discussed earlier, right? That's also optional, right? It's not necessary that every time you go ahead and perform the hierarchical view of something, right? But there is option, right? So if required, if you feel that this is going to give you a better view, right, of whatever information you want to convey through your visualization, yes, you are right. You are free to go ahead and use them. Similarly, the groups. Okay, so even in the groups, right, you can see that we can actually right try to make the groups of the data, various types of data that are present, and right, you can try to gather the information related to that group, and you can compare that with the other groups. So visualization becomes what you call more effective, I would say. So that you can see here on the right side, you can see people standing, right? When we make a group and we say that, okay, this color means something like this, that gives you, right, more info, that makes the graph more informative, I would rather say. Okay, and then this already we have discussed. Okay, measures and dimensions, right? So this is another view what we have seen. Dimensions, independent variable, right? And normally this is text. It's not compulsory, it's a normal. Okay, usually it is a text, like state wise. Earlier we gave an example, state wise cost. So state name some number, state name some number. So you see the number comes on the y-axis. That's why, right? Measures are normally dependent variable and it's a function. So function means it has to be a number. So this is, again, this is not always, but most of the time is what we have observed, we have put up over here. Dimension is usually a text and measure is usually a number, because depending on something I'm writing a value, right? So this can be anything, so that's why it can be even text, right? Even numbers are fine. So at 11 o'clock this much, at 12 o'clock this much, so temperature versus time, right? You can see that there you don't see dimension becoming a number. Sorry, there you don't see dimension becoming text, but yes, there are, most of the time is what we have written. Usually it's expected as a text. Okay, so that brings us to the end of today's session. Any doubts we have, we are free to go ahead. Okay, I'll show you one last slide. That's actually is what I was talking about earlier, right? Anyway, so just want to show that, right, there is a lot of competition between the Microsoft, right, and the Tableau. So it's actually, there was a software called Salesforce. They have acquired the Tableau now, right? So because of which it's shown as Salesforce. But anyway, the Tableau itself. Okay, so a lot of competition between those two. All right, any question? Sure, sure, sure. All right, so I appreciate all your efforts and patience listening to this session. So have a great day. We'll meet in tomorrow's session and we'll continue. Thank you so much.